Welcome learner to our today's discussion, and this is a topic in Form 3, further logarithms. Now, before we start with this topic, we need to be sure of the objectives, and the objectives of this topic is that 1, you should be able to state the basic laws of logarithms. That is one of the objectives. The second objective is that you should be able to solve logarithmic expressions and equations. This is the second objective. Then the third objective is that you should be able to apply the concept of logarithms in different computations. Those are the major objectives of this topic. And now, just to do a recap of what you covered in Form 2, we need to look at indices, where you talked about the indices. So let's just do a recap of what you covered in Form 2. This is indices. You covered on a topic called indices in Form 2, and you find that in this topic you came out, or you outlined several basic laws that you use when you are solving computations that involve indices. So can we look at just the laws of indices? The laws of indices. The number a raised to power n, then you multiply by another number a raised to power m. This will give you a raised to power n plus m. And remember that you said that n is the index, a is the base. This is the base. So in other words, you say that when you multiply two numbers, or two numbers with the same base but different powers, you just simply need to factor out the common base, then you add the two powers. Then the second law, you say that if you have a base a raised to power m, then you divide by a raised to power n. Again, because we have the same base, you just simply factor out the common base, then you get the difference between the powers, and that is the second law. Then the third law, you say that you should, if you are given a raised to power n, and again it's raised to another m, then you say that these will be the same as saying the a, then you multiply the two powers. So you multiply by m, and this will give you a and m. So these are the basic laws of indices. Then you talked about the conversion of index notation to logarithmic notation. So can we just have a review of that? Let's look at conversion of index notation to logarithmic notation. Conversion of index notation to logarithmic notation. So under this, you say that the general form of an index form, if you are given a raised to power n is equal to m. This is what we call an index notation. And now we want to convert now the index notation into logarithmic notation. And bearing in mind that this is our base, and this is our index. The index is the same as the power. We call it the power. So to convert an index notation into a logarithmic notation, what you do, you just write the log, then you take the base a, is written as a subscript, then the value of the index, or the answer of the index, becomes your log, so this becomes m, then the index becomes your answer. So when you are converting an index notation to a logarithmic notation, you simply take the base, you write it as a subscript of the log, then the answer to your index notation becomes your log, then the index itself, or the power, becomes your answer. And this is what we call logarithmic notation. So you should be able to convert a logarithmic notation to an index notation and vice versa. You should be able to do that. So now having captured this, can we go straight to our discussion today? That is further logarithms. The further logarithms. Now, under further logarithms, we are going to look at basic laws of logarithms. As we saw that with indices, you learned about the powers, or the laws of indices. So we are again going to discuss the laws of logarithm, because these laws of logarithms are just captured, or they are just extracted from the laws of indices. So as we have said, we have the laws of indices here, and then the law of logarithm. So I want us to start with the first law of indices, which says that when a is raised to power n, you multiply by a raised to power m, gives you a plus m. So from this first law of indices, we get the first law of logarithm, that says that when you have a log to base a x y, this is the same as saying log to base a x, but because here we have a multiplication and we say that we add here, so you can just add log to base a y, and that is our first law of logarithm. The second law of indices, you say that when you have a number a raised to power m, then you divide by a raised to power n. This gives you a m minus n. So from this we can form our second law of logarithm. And our second law of logarithm, we say that if you have a log to base a and you have x divided by y, this is the same as saying log to base a x, division will mean subtraction, so you have minus log to base a y, and that is our second law of logarithm. Then we look at the third law of indices, where we have a raised to power n, then raised to power m, which gave us a raised to power n m. So from this we form our third logarithmic law. So we say that log to base a x raised to power n, this is the same as saying n log to base a x. So now we have only three laws of logarithm. We have only 3 laws of logarithm. Now, from these laws of logarithm, now we should be able now to do some computations. Like for example, I want us to do this example. So we are talking about example, and this is example 1. You are told that express the following into log A, log B, and log C. And then we have Roman 1. We are given that log, this is log into A, B, C. Then Roman 2, we have log AB over C. Then the third example, or Roman 3, we have log into A, BN divided by CM. We are told to express all these into log A, log B, and log C. Now I want us to see what you should do with this. So we look at the solutions. Let's look at the solutions. So number 1, this solution, Roman 1, we are given that log A, B, C. One thing that you must understand, learner, is that between A and B we have a multiplication sign. Between B and C we have a multiplication sign. So to write this in terms of log A, log B, and log C, so it should be log A. Between A and B we have a multiplication sign, so we can have an addition sign there. Log B, this is log B. Then we have another multiplication sign between B and C, so this will give you log C. And this is now the form that you are required to write your first notation in. So let's look at the second one. The second one, you are given that log AB over C. So this should tell you that between A and B we have a multiplication sign, but this is division, so we have a minus somewhere. So if we take it to be log AB, this division we have it as a minus log C. But now you see this one, you can break it again, so it will be log A plus log B minus log C, and that becomes the value of your second logarithm notation. Then the third one, we have log ABN over C raised to power M. So this means what? This will mean it is the same as saying log AB raised to power N, then division becomes minus log C raised to power M. But we can also break this again. So we will have log A plus log BN minus log CM. But remember the third law of logarithm, we say that this power can be taken behind the logarithm. So we can have log A plus N log B minus M log C. So this is now the format that you are supposed to leave your answer at. That is the form that you need to leave your answer at.